Hello, in this episode, we're going to discuss how to solve neural network using Keras functional API method. And this is another method along with sequential, a popular method to solve neural networks. It is a little bit, it requires a little bit more typing, but it's more general. And in the future, we will see how it works out. But for now, let's just show how it looks like. We will use the Kaggle lone default data. We have seen in the earlier episode. So the lone default data here, it's in Kaggle, lone default prediction. If you click the download button and you have to sign in for a free account for Kaggle to do that, then you can download the default FIN. And I already did that. And if you look at it, it has 5 columns, the index being the serial number of the 10,000 observations we have here for individual borrowers. And then the second, third, fourth columns are whether it's an employed or not employed, bank balance, and annual salary. And the last column is basically a 0-1 indicator whether the borrower defaulted or not, 1 being default. Okay. All right. Again, the neural network process is very similar as in the sequential method. You load the data, define the model, meaning decide on how many nodes for each layer or how many layers you want. And then compile the model, meaning how are you going to measure the losses, what kind of solver you want to use to find the errors, and how to fit the model means use the data to find an optimal weights through the backpropagation processes. Then you evaluate how good your training was and then make predictions. Right? So we are going to use the functional API method. So pretty much the early part is very similar to the sequential method. First, you set up the environment, meaning loading all the libraries you need. In this case, we are going to use the model method. It's a little bit flexible. And then in the Keras layer, we'll use the input and relu layer and also dense layer. The next step is to load the data, and we'll have to upload it and then store it in a data frame. So a DF is the name. Again, it's a good idea to check the data, and I'm going to remove the question marks, the column names, and the lowercase, and remove the spaces. And then I'm going to delete index column because I don't use them for my prediction. And then check whether their missing variable is none, and then duplicate it. They're none, the data is fairly clean. And then set the training variables X. First, I convert to NumPy, and then the last column is what I want to use as an output target, call it Y. And then the early three, the first 3 columns are my X variables. So I use them. So now it's the new part, the neural network functional API. In the sequential method, what we did was we start with sequential. Remember, let me just invoke that here. In the sequential method, we call sequential, have it in a model, and then keep adding the layers. So that was the simple thing to do. But sometimes you want to have, let's say, multiple output designs and all this. But there are many flexibilities people want. So in this case, what people do is the functional API method, and it starts with the input here function. So in the input, and the functional API explicitly designs an input, and then give the shape. The shape has to be 3 here because we have 3 columns as an X variable. Okay, you can name it. You don't have to name it, but you can name it. So, but this one is fixed. In the future, you can have input from different sources, from 2 different data. So you can have input and then have some input 1, and then input 2, and then have some input from other place, and then merge them, and then send it to another layer. Here we just do the simplest stuff. We have just from input 1 input data, and which has 3 columns, calling the input function, and then call it something. Let me call it NN input. And then we have the dense layer. I will have 5 nodes. I can have 10 or something. Activation function has to be defined. What's really important is that my input here, and I named it NN input, I am using that that's my starting point. So that comes in and then sends it out to 5 nodes, and I call it hidden 1. I can repeat it if I want to have more layers. The hidden 1, I feed it hidden 1 here to a dense layer of 5 nodes. Of course, I could have made it 15 if I want 15 nodes, and I can change the name here to sigmoid or something else. Let me not do this, and then do this. If I want to, I can keep doing it, isn't it? I can make hidden 3, which gets the data from hidden 2, and then so forth, okay? So, but let me not do that. So after hidden 2, so it takes hidden 1 and then have 5 nodes, and that's a relu, and then it spits out the output hidden 2. The hidden 2 goes to the final output, and it's a dense layer with 1 node, and this 1 is important. You cannot change it because your output has 1 dimension. And here the activation is sigmoid. Again, that's the sensible thing to do because the y variable is 0, 1. And then once you have defined the input-output structure from the input hidden 1 to hidden 2, hidden 2 to out. And then the overall path is that you get an input and you get an output here, isn't it? And set it up as the whole model. So there's a model function. So this is Google-defined Keras function model. And then how it works out is that nn input here, and then the output is nn out. And so the whole thing is my model. So this is my name. I could name it my model, whatever I want to, okay? So this is how you define the network structure. It is a bit more involved, but then I have a flexibility later on. We will see in the future episodes that I can have the previous hidden to go to one output and another output and multiple output, and then have some different complicated things done. But here in a streamlined way, I'm basically showing how to do a functional API as a streamlined, fully connected neural network, just like here. And the analogy would be here. It's an identical thing, except I've done it in a different method. Okay? Which this functional API basically traces what comes out, goes into the next layer, and then to the next layer, and to the next layer. And then overall, it's an input to output relationship. I call it my model. Afterwards, it's actually the same. So once I have done it, I can just compile my model. It's identical as the sequential method. I'll fit it. Okay, and again, 50 epochs. Okay, I finished fitting all the 50 epochs. After that, we can check the evaluate the model given X and Y and compare it to the prediction and see how many times it's accurate. It's the model evaluate, the Keras evaluate command. It gives us 96% as before. And then we can make predictions, meaning the predict command here, and given X, it will make predictions and see how many times they are correct. And it's done. So this shows how to use the functional API method. It's the alternative to the sequential method that's provided. For the time being, for simple stuff, sequential method is simpler and most of the time we'll use it. But later on, when you have a more complex neural network structure, functional API, which traces the input versus output in each layer, gives more flexibility in designing complex neural networks. We'll see it in future episodes. Thank you for watching the video.